Hello friends, this is Dr. Siva Nagaraju, Associate Professor from IARE. Today we are going to discuss frequency modulation of single tone. In previous we discussed about the angle modulation, the basic concepts. In the basic concepts we discuss generally the phase modulation and frequency modulation. But in this video, we are going to discuss single tone frequency modulation. So, the frequency modulated wave in the time domain is given by S of t, which is equal to AC cos of theta of t. So, theta of t is the angular argument what we discussed earlier. So, now the sinusoidal modulating signal, what is our baseband signal, is defined by m of t, which is equal to am cos 2 pi fmt. So the instantaneous frequency of the fm signal is given by f I of t, which is equal to fc plus kf m of t. Here fi of t is the instantaneous frequency, where fc is the carrier frequency, m of t is the message signal, and kf is the sensitivity of that modulator. So in the next equation, we are going to substitute that m of t, that means message signal. So finally, our instantaneous frequency, which is equal to fc plus delta f cos of 2 pi fmt. Actually, this is our third equation. Where delta f, which is equal to kf am, and it is called the frequency deviation. And coming to the angular velocity omega I of t is the rate of change of theta of t. Why theta of t is the angular argument. So here that angular velocity, which is related to this angular argument, and which is written as omega I of t, which is equal to d by dt of theta of t. That means derivative of theta of t. So already you know angular velocity omega I of t, which is equal to 2 pi fi of t. So we are going to substitute this value. So we got 2 pi fi of t, and which is equal to d by dt into theta of t. So finally theta of t, which is equal to, here the derivative moves to that left hand side, it's converted into integral. So integral 0 to t 2 pi fi of t dt. This is our fifth equation. So here we are going to derive that single tone modulation of this frequency modulation. Now we are going to substituting equation 3 in equation 5. So once we are going to see what is our equation 3 and what is our equation 5, and then how did we get this theta of t value. So fi of t is fc plus delta f cos 2 pi fmt. So this is our third equation. And theta of t, which is equal to 2 pi fi of t, integral 2 pi fi of t dt. So this is our fifth equation. So substituting fi of t value in this equation. So here we are going to derive this one. Theta of t, which is equal to integral 0 t 2 pi fi of t dt. So integral 0 to t 2 pi, and we go for this Fi of t value, Fc plus delta f, Fc plus delta f cos 2 pi Fmt. So of this Fc plus delta f cos 2 pi Fmt dt. So here you have a theta of t, which is equal to integral 0 to t cos 2 pi Fit dt. So this is our fifth equation, and this is our third equation, Fc plus delta f, Fc plus delta f cos of 2 pi Fmt. So here we are going to substitute this Fi of t value. Now apply this integral inside of this equation. So 2 pi Fc dt plus integral 0 to t 2 pi delta f cos 2 pi Fmt dt. So this is our equation. So here this is 2 pi Fc as treated as a constant put outside. So having integral 0 to t dt. So 1 dt, so it is a t. So finally we having the first term is 2 pi Fct, and the second term what you written as 2 pi delta f, this 2 pi delta f put outside, and here you go to integrate this cos 2 pi Fmt dt. So we are going to integrate this cos term, we got sine. So here this is in the form of cos of at. So get integrating this cos of at, you get sine at by a. So 2 pi Fct plus 2 pi delta f, and integrating this term get sine 2 pi Fmt divided by 2 pi Fm. So apply the limits from 0 to t. At 0 we get sine 0 is 0. So having only the upper limit. And this 2 pi is going to cancel. And finally theta of t, which is equal to 2 pi Fct plus delta f divided by Fm sine 2 pi Fmt. So where delta f by Fm, which is called as beta, then we get that value of theta t, which is equal to 2 pi Fct plus beta sine 2 pi Fmt. So now substituting this equation 6 in equation 1. So what is the sixth equation is this one. So you go to substitute this equation 6 in the first equation, then you get the final frequency modulated signal, that is S of t, which is equal to AC into cos of 2 pi Fct plus beta sine 2 pi Fmt. Why I say S of t, which is equal to AC cos of theta of t. So you got theta of t from equation 6. Now you can substitute, you get this equation S of t. And now the modulation index. So the modulation index is defined as the ratio of frequency deviation to the modulating frequency. So in the last expression, we given that beta, which is equal to delta f divided by fm. So that is our modulation index. Whereas in amplitude modulation, we denote this modulation index as mu. Now the frequency deviation. The instantaneous frequency of the FM signal varies with respect to time. The maximum change in the instantaneous frequency of the from the average value carrier frequency Fc is known as frequency deviation. So delta F, which is equal to Kf m of t to the maximum. So the maximum change in the instantaneous frequency from the average value of the carrier frequency, we can call as frequency deviation. So next one is the bandwidth. So by Carson's rule, we can define the bandwidth in FM. That is BW, denoted as bandwidth, represented as bandwidth BW, which is equal to 2 into delta F plus FM. 2 into delta F plus FM. So that is our Carson's rule. And the properties of this FM. So having two properties. One is narrowband FM and second is wideband FM. So these are the two properties of FM. And generally we can also call as two varieties of FM also. So what is a narrowband FM? A narrowband FM is a FM wave with a small bandwidth. The modulation index beta of NB-FM is small as compared to 1 radian. That means the beta value is very less. So depending on the modulation index, we can define that FM which variety. When coming to the wideband FM, the wideband FM has a much larger value of beta, which is theoretically infinite. Theoretically, it is infinite. So, in the coming videos, we are going to discuss about narrowband FM and wideband FM. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.